Hello, in this video we'll be going through limits and L'Hopital's rule for A-level further maths. Let's get straight into it. So, what is a limit? You might have come across this in GCSE maths or A-level maths before, directly or indirectly, but essentially, a limit is whenever the output value for a function is getting closer and closer to a certain value as the input value is basically getting closer to a specific value as well. The most obvious example of this would be any sort of exponential graph, right? Or where in this graph, for example, as the input or the x is getting closer and closer to infinity, the output is getting closer and closer to e, right? You can see like the red is getting closer and closer to it, but it never reaches it. Another example you might have seen would be like the tan graph, right? So the graph for tan theta. So if you remember, it's something like that between minus pi and pi. So we call minus pi and pi limits as the tan graph sort of is inching closer and closer towards the pi and minus pi limits, right? So one of the sort of key uses for the knowledge of limits is differentiation from first principles. How you go about doing that, I've drawn a little diagram as most people don't sort of know where the f of x and f of x plus h comes from and stuff. So I'll take this step by step. Imagine you have a function, f of x, right? A random point in this function, the x coordinates x, right? And let's say there's another random point where the x coordinates x plus h. Now for this function, if this is the x coordinate, the y coordinate will be f of x, right? X inputted into the function. And the y coordinate for here will be f of x plus h, right? So if we were to calculate the change in y and the change in x for any random function, or working out the gradient of it, right? So change in y over change in x would be nothing but f of x plus h minus f of x over x plus h minus x, right? This is just h. So this is where the sort of differentiation from first principles formula comes from. Now, where limits come into this is that essentially what we're trying to generalize with the formula is that we're trying to make h, right, or this distance between these 2 points infinitely small. So what that means is, right, that we'll say that the limit as h tends to 0 of fx plus h minus f of x over h will give us the general differentiation or the gradient of any function f of x at any point x. Okay? So let's sort of put this into practice. Like a classic example, right? Let f of x equal to x squared. Let's try and differentiate this from first principles using the limits. So as the limit h tends to 0, okay, f of x plus h minus f of x over h becomes, because h is getting infinitely smaller, so it's tending to 0. I said never quite hits 0, but it's getting infinitely close to it, so it's tending to 0. So as h is tending to 0, we'll get x plus h squared minus x squared over h, right? This will lead to x squared plus 2xh plus h squared minus x squared all over h, right? Plus x squared minus x squared instead. And never forget the limit as h tends to 0, okay? And this will lead to limit as h tends to 0 of 2xh plus h squared over h, right? So where this is going, obviously, is as limit h tends to 0, right? 2x plus h. So obviously as h is tending to 0, this whole thing will just be 2x. Therefore, the differentiation of x squared is 2x from first principles. This is one of the most common and first things we learn about when we learn about limits is differentiation from first principles. I want you to just keep this formula in mind. I think this will be most likely provided to you in the formula booklet as well. Make sure you double check that though. Okay, now that you sort of understood what limits are, let's talk about L'Hopital's rule. So L'Hopital's rule states that to find the limit of a function, f of x over g of x, right? Sometimes it's nice and easy where you just get the limit, but sometimes you'll get two functions, right? Where as x is tending to a, you get either 0 over 0 or infinity over infinity. And these are the two conditions. Where you can apply L'Hopital's rule. Okay? So if you're trying to find the limit of a function as x tends to a, and f of x over g of x ends up being 0 over 0 or infinity over infinity, then you can use L'Hopital's rule, which just says limit of f of x as x tends to a, f of x over g of x, is nothing but the differential of fx over the differential of gx. And another thing, what's really interesting about this, is that if this thing ends up being 0 over 0, infinity over infinity as well, you can keep on applying L'Hopital's rule until you get the right solution. We'll see two examples, one where you have to apply it multiple times just so you get the concept, okay? So what he officially states, that you might see this term thrown around in the exam, so I'll let you know. These are called indeterminate solutions. So if the limit is indeterminate, then you use L'Hopital's rule. 0 over 0, infinity over infinity. Those are the only two conditions, okay? So in the first example, right, I'm trying to find the limit of this function as x tends to 1. Okay, so let's plug that in. So it becomes 1 cubed minus 1 over 1 squared minus 1, right? Which is obviously just 0 over 0. So this meets the condition. It meets this condition. So we can use L'Hopital's rule, right? So we can do limit of x tends to 1 of the differential of that. So f dash of x over g dash of x, right? Which would be limit x tends to 1 of 3x squared over 2x. And if we plug in 1 here, for example, or as this goes to 1, this will just become 3 over 2. So the limit of this, under normal circumstances, without L'Hopital's rule, would have been 0 over 0, which is just invalid, right? But using L'Hopital's, and if we differentiate the numerator, differentiate the denominator, plug in 1 again, we find its actual limit of the function. So you see how it's very, very, very helpful in some scenarios. Okay, so this is the second and last example I'll take you through today. And in this one, as you can see, limit as x tends to 0 of this function. So firstly, when you try to do it normally, 2 minus 2 cos of 0 over 0 squared, you can clearly see like this is just 0 over 0. Hence we met the criteria again. Okay, so let's try differentiating it once and seeing what happens. So f dash of x and g dash of x become minus 2 cos x just becomes 2 sine x, and x squared just becomes 2x. So as x, if we substitute in 0 into this equation, sine of 0 is just 0, and 2 times 0 is 0. So now you see, we've already differentiated it once, right? This is the first time we differentiated it, and we've got 0 over 0 again. Remember what I said earlier, you can use L'Hopital's indefinitely, basically until you keep on getting 0 over 0 and infinity over infinity. So what we can do is, we can just find of x as limit x tends to 0, right? So what that would be is 2 sine x differentiated again would just be 2 cos x, and 2x differentiated would be 2. Now, if we set the limit x tends to 0 on these guys, it'd just be 2 over 2 or 1 being the final answer. So as you can see, you probably already had most of the prior knowledge required for this topic from GCSE or A-level maths. But yeah, the most important thing you need to know is L'Hopital's rule, and the most important things you need to know for these is when you can apply it. 0 over 0, infinity over infinity. When the limit, when x tends to is indeterminate. Okay? I hope this helped. If you have any specific topics you'd like me to run through, any specific questions or anything like that, email me. My email is down in the description below. Thank you so much for watching. I'll see you in the next one.